Hello everyone. So in this video, let us talk about the first three problems from the latest LEETCODE weekly contest 288. So let's start. All the three problems are not too much difficult to understand, as well as the logical part is also not difficult. Yet the implementation, the code writing part can be a little bit difficult. But let us try to understand all of them one by one. The first problem is largest number after digit swap by parity. So the problem statement goes like this: that you're given a positive integer nums. Also, you may swap any two digits of nums that you have the same parity. So as you can see that the number is given to you as here nums. Now you can swap out any two digits that have the same parity. By parity, I means that both can be either odd or even. So you can only swap even numbers and odd numbers. Digits, sorry. Now return the largest possible value of nums you can get after doing this operation any number of times. Now when I see such type of problem, let us write down any number. Let us take the first number itself. If I just take the first number, that is 1 2 3 4. Let's say that the number is 1 2 3 4. Now what I can understand from the problem statement is that I can only swap even position numbers. So I can swap this and this, or I can swap the odd position numbers, that is this and this. Now let us write down some more digits. Let's say it is only 4 5 4. This is the overall number. Now I can also swap this and this and this. So when I have the no boundation on swapping, but I can only swap even positions, then what I can do is that I can swap all of these positions anywhere between themselves. What I mean by this is like, because all the positions are even, I can bring this position here, I can bring two this here, I can bring two this here, anywhere. But the main thing that you have to remember is that there is no boundation on how I can move these even numbers around. But the only boundation is that the position on the even number should be fixed. I cannot bring a even number here because even number only occurs on this position. Okay, so the first thing is that I have to remember ki where these even positions are, even number are, and then because in the end I want the number to be as maximum as possible. So my main goal is that I should bring all the even numbers in the same position, but the maximum even number should come here, then the maximum and the third maximum, so on. Okay, and similarly for odd number as well, that first odd maximum odd number should come here, second odd maximum come here, and so on. So that's the overall logic. What we will do is that we will first store out at which position we have even numbers and what position we have odd numbers. How we can do that? We can actually just go from left to right over this number, or like you can also like bifurcate this number one by one. Whatever digit you will see, you see that okay, the first digit is even, so put even here. Then the second digit is odd, you put odd. The second digit is even, odd. So you make a string that stores what digit is at what position. That is the first is odd, even, odd, and on even. And similarly, you can also store, like you can make a container or a vector to store out what all even numbers I have. So let's say I have even numbers 2 4 4 8, and the other numbers are 3 5 3, the odd numbers, let's say. Then we have this string also that have what, because these even and odd should be reflecting here, so I have to put the maximum even, like the maximum even number, because let's say that we first saw odd, so we have to put the maximum odd number here first. So I will put 5 here, I'll see even, so the maximum even among here is 8. Then I have to see again odd, so the maximum among all of them is, let's say, 3. Then I see even, so even among all of them is, let's say, 4. Then I'll again see like maybe this is again even, so the maximum left among all of them. So I have to also keep track that okay, I've used this, so I will not use this again. I've used this, I will not use it again. Now the other 4, so I will put other 4 and so on. So that's the overall logic we will be using to solve this problem out. So let us move on to the solution part. So what I've done is that we have to first form a string. So this is forming out a string. Then there are two vectors to sort what odd and even digits we have. Then we'll iterate over the nums. Start out the large digit. If it is even, we'll push an e in this string, and as well as push the digit we have in the even vector, as well as similarly do for the odd. Then we have the string as well as all the digits that we have. Now we'll sort them, because we have to like place them in such a way that we have to place the maximum even number and maximum odd number and so on. Then this is the answer, the final answer that we will building out the number itself. What we'll do is that we'll have to append 10. 10 means that we'll add one more digit because we are directly forming out our answer. Then if the number you want to append is even, because the current position at which I want to append is even, I will take an even number. But because it is sorted in the increasing order, the last number is the maximum. So I'll take out the last number from even, because that is the maximum number, and pop it out so that we'll not use it again. I'll do the same thing for odd as well. If I want to place an odd digit at the current position, because I have seen that the position string that we have built tell me that we have to place an odd digit, then I will place an odd digit, as well as what I'll do, I will pop out that odd digit, because so that I will not use it again. And in the end, we'll have the final answer. And that's the overall logic, nothing much complicated. So all the codes will be in the description of this video. So if you want any of these codes, feel free to check out those codes. So let's move on to the next problem. The next problem is minimum result by adding parentheses to expression. So I'll tell you in simple terms, you are given an expression like this. It has a plus sign as well as two numbers, that is on the either on the left and right side. Now, what you have to do is that you have to insert a pair of parentheses like this. Only one parenthesis, nothing much, such that the new outputted expression that will form is of the smallest value possible. By smallest value, as you can see that this is the expression. If you can get this expression, then it is like 2 multiplied with 47 plus 38, and the answer is 170. And if you just add both of them out, it is like if you form out any other expression, then this is the smallest among all of the expression. I'll tell you how the expressions are formed. But the other thing is that what you have to do is, this is one of the line, that the left parenthesis must be added on the left side of plus, as well as the right parenthesis must be added on the right side. So it cannot be happen that you just divide it like this, 2 multiplied 47 plus 38 and so on. So it is guaranteed that given that you have to place one parenthesis on the left side of 1 and one parenthesis on the right side of 1, like plus sign. And okay, that's the whole problem. So let us move on to the drawing board to understand it more clearly. So if I just erase out this out. Okay. So let's say that we have a string. Let's say like let us take the first string as only. The first string is 247 plus 8. Now what you can see is that I have to place one parenthesis on the left hand side of like this plus sign, and one parenthesis on the right hand side. So I have different options. Like I can place one parenthesis here, I can place one parenthesis here. Okay, and similarly I can place one parenthesis here and one parenthesis here, one parenthesis here, or one parenthesis here, one parenthesis here, and one parenthesis here. So there are different options we have. Now, so let us say that if we just do a brute force way, then the expression length is very small, and yes, and thus we can do a brute force way. Now by brute force way, what I mean is, because I want to place one parenthesis on the left hand side of plus and one parenthesis on the right hand side of 1, we can first bifurcate this string on the basis of parentheses. We can see that, okay, how much expression of this whole expression we have, all the numbers we have are on the plus side on the left hand side, as well as how many numbers we have on the right hand side of plus. Then we have the two numbers that we have. Then what we'll do, we will try to put a opening parenthesis on the left hand side of the left hand side of expression, and the like closing bracket on the right hand side of parenthesis. And whatever the expression we have, we'll try to find out the value for that. And whatever value we'll get, we will just minimize the value from all the variable, like all the possible values we'll get. So that's the whole logic. I'll take you down directly to the code part. But that's the whole logic around here. Not much complicated because it is just a brute force way. So what we'll do is that we'll first find out the position of plus. Now by finding out the position of plus, we'll get that, okay, this is the final position of plus. We have to get a right string and the left string. So what we've done is that we are using the substring function to find out and divide the string from 0 till I and from I plus 1 till end. Okay, so that we have the two expressions. Now we have the two expressions left and right. These are the lengths of that. This is the answer, final answer we will be turning out. And minimum value, what we have to do is that we have to like start doing our minimum value. So what we'll do here is that, see, so what we'll do is that I equal to 1, I less than equal to length. So we will start putting out an opening bracket on the left hand side of this size, as well as the closing bracket on the right hand side. Now we have the final expressions. So the final expression is, let's say that if we put a bracket here and here, okay, then we have 4 parts now. On the left hand side also there is one part which is on the left side of the left bracket and on the right side of the left bracket, as well as one part is on the left side of the closing bracket and the right side of the closing bracket. So this part will be multiplied with the summation of this part, as well as this whole will be multiplied with this part. Fine. So that's the whole logic here. So what we'll do is that we'll first find out all the 4 parts according to the I and j we have. like whatever position we are placing out our brackets. And then what we'll try to do here is that we'll use this modified like string to integer function, because the integers are very small, so that we can use the string to integer function. But if there is nothing, then we have to return 1, because let's say that we have to take this example that we have 247 plus 38, we put one bracket here, one bracket here, so there is nothing on the left hand side of this, so it is empty. So if it is empty, it actually just means that it is multiplied by 1, and similarly it is multiplied by 1. So that's what we are trying to do here, is that this is a modified SQL function, that if it is empty, then we return 1, or else we just convert the string whatever we have to integer. So what we are trying to do is that we will add the part 2 and part 3, multiply it on the left hand side with this, and on the right hand side with this, whatever value we'll get. If, as you can see, that if minimum is equal to -1, then we'll update, or if minimum is greater than the value, like the value we'll get is smaller, then we'll update this. Because why we have done this, like you can have also chosen a very large number also, like chosen a very large number, but I do not know the, like, considering the number can be very large, what we can do is, like, you can store out 10 by 18, then you don't have to like use it -1, you can just choose a very large number, and then you just have to minimize that number with value. If it is smaller, what we'll do, you will find out the new expression. The new expression is part 1 plus, you'll do a like opening bracket, part 2 plus part 3, then closing bracket, and part 4. So this is the final string that you'll got, and if the answer is smaller, like you will update this answer and you'll get the final answer as it is. That is the overall logic for the second problem. The third problem is maximum product after k increments. So the problem statement is very simple. You are given an array of non-negative integer nums and an integer k. As you can see, this is the nums and k. Now in one operation, you may choose any element from nums and increment it by 1. So like you can choose any number from nums, increment by 1, and you have to return the maximum product of nums after at most k operations. Now you can choose, like, you can just means that you are taking one number one by one from k and adding that one number in nums. Now what you have to, in the end, you have to do is that you have to maximize the product of all the numbers in nums, and since the answer can be very large, you have to just do it with modulo of 10 to the 9 plus 7. Okay, now what I thought about this problem is, okay, we have different numbers and we have to add some number operations of 1 to all the numbers. So let's say that we have the number 2 and 3 in the array, and we have to add 1 by k equal to 1. I have two options. Either I can add this one to this number, and I can add this one to this number. Let us take both of the operations. If I add k to this number, like 1 to this number, the number will become 3, 3. And if I add to this number, it will become 2, 4. Now this number will become 9, and this number will become 8. So what does this actually mean? It actually means that we have to add the number to the smaller number, whatever is the smallest number. Why? Because if we keep on increasing the maximum number and there's a very small number that is 0 in the array, it will eventually turn, like, it will make all the numbers in the arrays, like the maximum product of all the numbers, equal to 0, which is also one very great point to be noted, that you have to find out the minimum number in the whole array incremented by 1, then whatever the next minimum number incremented by 1, and so on. Not the minimum in the static array, but what is the updating array. By updating I mean, let's say that we have numbers like this, 1, 2, 3. So the minimum among this list is 1, so I will update this 1 by 1, so it will become like 2, 2, 3. Now in this list, what is the minimum? 2, so I will update that 2 by 1, it will become 3, so it will become like 2, 3, 3. Now let's say that I have one more k, I have to update one more time 1k, so I will update the smallest in this list, that is this 2 only, so it will become 3, 3, 3. So what does this actually mean? We just have to find out the minimum in this updated list, whatever we have, and increment that smallest number by 1, and you have to keep on doing that number, like operation k times. And because the k is pretty large, like 10 to the 5, I have to do this operation 10 to the 5 times, find out the smallest number. And whenever I have to find out the smallest in a very dynamic list, one thing which comes to my mind is parity queues. Parity queue will help us to find out in very efficient time complexity. So what I'm trying to do is that I will keep on updating my list. I will keep on doing this operation 10 to the 5 times. So that's the logic. I'll first push all the numbers that we have in the parity queue so that the top element is the smallest. So you'll define a parity queue like this. This will greater int will make the top element to be the smallest. And then what I'll do is that I will do this operation k times such that I'll pop the top element and then increment the top element by 1 and then push back that top element, so that after k operations I have a list such that all the numbers are updated by k times. Now I have to just do the multiplication of all the numbers mod this m, the 10 by 9 plus 7. So either like you can do modular arithmetic, or I have a complete very good video on that, how to do modular arithmetic. So I'll don't go into the fuzziness of modular arithmetic. I'll just use few functions. Those functions are like just two liners. So as you can see that I've written two liner functions, mod and multiplication functions, and those functions will help me tackle out any of the modular arithmetic problems, and I don't have to think about how to do modular arithmetic. So the basic logic is that if you do modular arithmetic, then a mod b, so if you want to do a mod b mod m, so a multiplied with b, so let's say that we have the number at a multiplied with b mod m, we have to multiply, find out that. So the answer is a mod m multiply with b mod m whole mod m. So that's the whole logic. So what I'm trying to do here is that I'll do the same thing. So what I'm trying here is that if I want to find out answer multiplied with x, I'll use this multiplication function. Now this multiplication function, what will do, it will just take a mod into b mod, the whole mod. And this mod is a function that will just do modular arithmetic on that particular x whatever we have. So we don't have to go over the hustle bustle of how to implement that, whatever mod we have to take, nothing else is required. You have to just learn these functions, and if you want to learn more about that, I have a separate video on that. You can just like search on Google, like YouTube, like modular arithmetic code explainer. You will get a complete video on that, so it will become more clear to you. And that is how we'll do modular arithmetic. We have the modular arithmetic to just multiply the answer and multiplication of all the numbers mod m in the answer. That's what we're trying to do here, and just return the answer. So that's the overall logic and code for all the three problems from the latest LEETCODE contest. If you have any doubts,